Okay, my dear students, today we discuss about the Kolbe'S electrolysis. So, Kolbe'S electrolysis, it is also useful for the preparation of alkanes, alkenes, alkynes, and also it is useful for the preparation of cycloalkenes. Okay, so first one, substrate. So, substrate, sodium or potassium salts of carboxylic acids carboxylic acids. So sodium or potassium salts of carboxylic acids involved in Kolbe'S electrolysis to give alkane or alkene or alkyne and cycloalkanes. Okay, so here it involved in Kolbe'S electrolysis to give alkane. The reaction mechanism path. So mechanism path free radical mechanism, free radical mechanism. Okay, so already you know free radical mechanism. Wood's reaction takes two types of mechanism. One is free radical mechanism, another one is ionic mechanism. In this case, the reaction takes only free radical mechanism. Okay, so this reaction also useful for the preparation of even number of hydrocarbons, not useful for the preparation of odd number of hydrocarbons. Another one, this is not useful for the preparation of methane. Okay, so next one, this mechanism, this process is useful for the preparation of 2 to 18 carbon contain hydrocarbons. It gives good yield when the alkane contain 2 to 18 carbons. So more than 18 carbons, the percentage of yield is very low. It is good for 2 to 18 carbon atoms. Okay, so when the branching is increases at alpha carbon, the percentage is less than 10%. It means the steric crowding increases, the percentage of product decreases. For example, sodium acetate percentage of yield is greater than sodium propanoate greater than, so alpha substituted, so CH3 it is a alpha carbon, it have a substitute. So this is a functional group. Adjacent carbon is called alpha carbon. Alpha carbon have substitute. When alpha carbon have substitute, steric crowding increases, the percentage of yield decreases. So it have less percentage of yield. You see another example, CH3, C double bond O minus, Na+. So maybe this compound cannot participate in Kolbe'S electrolysis. When the branching chain increases, the percentage of yield decreases due to steric crowding. When the alpha substituted carboxylic acid salts involved in Kolbe'S electrolysis, the percentage of yield decreases, the percentage of yield less than 10%. Okay, now here the reaction takes in two types of mechanism. One is, the reaction takes two types. One is intermolecular Kolbe'S electrolysis, another one is intramolecular Kolbe'S electrolysis. Intermolecular Kolbe'S electrolysis means the reaction takes between the two molecules. Intramolecular Kolbe'S electrolysis means the reaction takes within the molecule. Okay, now first you see one example. This is the carboxylic acid salt. So 2 moles of carboxylic acid salt undergo electrolysis. So in electrolysis takes in presence of electrolytic solution. Okay, for example, NaCl, it is a bad electrode. It is a bad conductor. Okay, but it is a good conductor in presence of aqueous medium or fused state. Okay, when NaCl dissolve in water, it easily convert into Na plus ion and Cl minus ion. So here electrolysis takes in presence of aqueous medium. Okay, in presence of aqueous medium, so first it dissociate into ions Rc double bond O minus plus Na plus. In electrolysis, there is two types of electrodes. One is anode, another one is cathode. At anode, oxidation takes place. At anode, oxidation takes place. Rc double bond O minus, another mole of Rc double bond O minus, loss of one electron. Now this oxygen valency contain how many electrons? So actually oxygen valency contain 6 electrons. 1 electron involved in bond formation. Okay, so 1 electron involved in bond formation, it have a negative charge. Okay, so here also 1 electron involved in bond formation, now it have 5 electrons, it have negative charge. The involved in oxidation, it means loss of 1 electron. Each carboxylate anion loss of 1 electron. So it loss of 2 electrons, they are converted to free radicals. Rc double bond O free radical, Rc double bond O free radical. Now the involved in homolytic cleavage, because the byproduct is gas, the byproduct is a neutral gas, it involved in homolytic cleavage, loss of CO2, 2 moles of CO2 to give R free radical and R free radical. This R free radical involved in bond formation to give alkane. Okay, so the reaction takes in presence of anode. At anode, alkane is liberated and carbon dioxide gas is also liberated. So the reaction takes in electrolytic solution. So solution means water. It undergo dissociation H plus and OH minus ion. At cathode, H plus ion accepting 1 electron. So at cathode reduction takes place. Here carboxylate anion loss of 1 electron. At cathode H plus ion accepting 1 electron, it is converted to hydrogen atom. 2 hydrogen atoms combine to each other to give hydrogen gas. So hydrogen gas liberated at a cathode. So remaining is Na plus ion and OH minus ion. So Na plus ion combined with OH minus ion, Na plus ion combined with OH minus ion to give NaOH. After completion of reaction, the solution contains basic character, the pH is greater than 7. So it is important question. So on Kolbe'S electrolysis, after completion of reaction, what is the pH? Is equal to 7, greater than 7, less than 7 are not predictable. So greater than 7, because after completion of reaction, the solution contains basic character. So it contains NaOH or KOH. So NaOH or KOH basis pH value is greater than 7. So it have basic character, the pH is greater than 7. Okay, so here 2H plus ion accepting the 2 electrons. It liberated hydrogen gas liberated at a cathode. Okay, so now in this case, carbon dioxide liberated at a anode, hydrocarbons also liberated at a anode. Okay, so in Kolbe'S electrolysis, which gas is liberated at anode? So hydrocarbons and carbon dioxide liberated at a anode, hydrogen gas liberated at a cathode. Okay, hydrogen gas liberated at a cathode. So you see another interesting example sodium formate. So general statement. So most of the lecturers says in Kolbe'S electrolysis hydrogen gas liberated at cathode. Which gas liberated at cathode? Hydrogen gas liberated at cathode. But given example, sodium formate undergo Kolbe'S electrolysis. Which gas is liberated at cathode and anode? Okay, now here you see already you know reaction mechanism. It undergo ionization. So this formate anion undergo oxidation. Hc double bond O free radical. Okay, so the loss of one electron. Now here it involves homolytic cleavage. So CO2 gas liberated at anode and also hydrogen gas liberated at anode. CO2 gas liberated at anode and also hydrogen gas liberated at anode. Another step, an electrolytic solution H2O dissociated to H plus and OH minus ion. At cathode, H plus ion accepting one electron, it is converted to hydrogen atom. Two hydrogen atoms combine to each other to give hydrogen gas liberated at cathode. In sodium formate, undergo Kolbe'S electrolysis, which gases liberated at cathode and anode? So sodium formate undergo Kolbe'S electrolysis, hydrogen gas liberated at anode, hydrogen gas liberated at cathode. So remaining part is OH minus ion and Na plus ion. So Na plus ion and OH minus ion combine to each other to give NaOH. So after completion of reaction, the solution contain basic character. It is a very, very important reaction. So the general statement, hydrocarbons liberated at a anode. But here hydrogen is not a hydrocarbon. Okay, hydrogen is not a hydrocarbon. So sodium formate undergo Kolbe'S electrolysis, hydrogen gas liberated at anode, hydrogen gas liberated at cathode. Okay, do you understand? Okay, so next one. In this reaction, disproportionation also takes place. What is disproportionation? In disproportionation reaction, one compound undergo oxidation, another one undergo reduction. It is called disproportionation. Okay, so but Kolbe'S electrolysis, major product is always alkane. Alkane is a major product. So you see one example: CH3, CH2, C double bond O minus Na plus. So CH3, CH2, C double bond O minus Na plus. This compound undergo Kolbe'S electrolysis, you get how many number of products? So here you get side products also, but major product is alkane. Already you know, here we get how many number of free radicals. So first one, these compounds undergo ionization. So CH3, CH2, C double bond O minus. You get 2 propanoate anion. It undergo oxidation to give free radical. CH3, CH2, C double bond O free radical. Okay. So this is the one free radical. Another free radical, it undergo homolytic cleavage to give CH3, CH2 free radical. Okay. So this is a free radical. Now CH3, CH2 free radical combined with CH3, CH2 free radical to give butane. This is a one product. CH3, CH2, CH2, CH3. This is a one product. So another possibility. So CH3, CH2 free radical reacts with another CH3, CH2 free radical to give ethane, CH3, CH3 plus ethene, CH2 double bond CH2. Okay, CH3, CH2, double bond CH2. So this is a product number 2. This is a product number 3. So another possibility, CH3, CH2, C double bond O, CH3, CH2, C double bond O free radical combined with this CH3, CH2 free radical to give ester. To give ester. Okay, so in all these products, the major product is butane. In all these products, major product is butane. So remaining products are byproducts. These are minor products. These are minor products. Okay, so next one, I give an example. In this reaction, you get how many number of products? So it is a type question. In this reaction, you get how many number of products? When sodium acetate, one is sodium acetate, another one is sodium propanoate, sodium acetate and sodium propanoate undergo homolytic cleavage, you get how many number of products? So it is integer type question. Okay, so here question is not which product is major, which product is minor. So generally which product is major? So alkanes are major product. So Kolbe'S electrolysis, it is useful for the preparation of even number of hydrocarbons, not useful for the preparation of odd number of hydrocarbons. So question is, this 2 carboxylate, sodium carboxylate involved in Kolbe'S electrolysis, which how many products are possible? Already you know how many free radicals are possible. So one is CH3, C double bond O free radical is possible. So another one CH3, CH2, C double bond O free radical is possible. So here it involves in homolytic cleavage, CH3 free radical is possible. Here it involves in homolytic cleavage, CH3 CH2 free radical is possible. So first one, CH3 CH2 free radical combined with CH3 free radical. So first product is CH3 CH2 CH3, this is a propane. Another one, CH3 CH2 free radical combined with another CH3 CH2 free radical to give butane, CH3 CH2 CH2 CH3 butane. Another possibility, CH3 free radical combined with another CH3 free radical, CH3 free radical combined with another CH3 free radical to give ethane. So here another possibility, this CH3 free radical combined with here you get product number 4, CH3 C double bond O OCH3. So another possibility, this CH3 free radical attacks here, you get another product. So CH3 CH2 C double bond O OCH3. So another possibility, this free radical attacks here, CH3 C double bond O CH2 CH3. This is the product number 6. When it attacks here, product number 7, CH3 CH2 C double bond O CH2 CH3. It is product number 7. So product number 8, it involves in elimination reaction to CH3 CH2 free radical, ethyl free radical involved in elimination reaction. Already you know, CH2 double bond CH2 ethyl is possible. So another possibility, CH3 CH2 free radical reacts with methyl free radical. Methyl free radical. So CH4 is possible. So total number of possible products is 9. Total number of possible products is 9. So that's why Kolbe'S electrolysis, it is not suitable for the preparation of odd number of hydrocarbons. This is not suitable for the preparation of odd number of hydrocarbons. Okay. This is not suitable for the preparation of odd number of hydrocarbons. It is suitable for the preparation of even number of hydrocarbons. In even number of hydrocarbons, alkenes are the minor products, but major product is alkane. Major product is alkane. But here you get different number of side products, alkanes. You cannot separate it by the fractional distillation. You cannot separate it by the fractional distillation. So that's why Kolbe'S electrolysis, it is not suitable for the preparation of odd number of hydrocarbons. Okay. So next one. So dicarboxylic acids, dicarboxylic acid salts, dicarboxylic acid salts. So here in previous case the reaction takes in presence of 2 moles. Okay, so it is called intermolecular Kolbe'S electrolysis. So here reaction takes within the molecule. Within the molecule, it is called intramolecular Kolbe'S electrolysis. So here it undergo ionization to give CH2, C double bond O minus, C double bond O minus. At anode, it undergo oxidation, loss of 2 electrons. It is converted into free radical CH2 C double bond O free radical, CH2 C double bond O free radical. Now here it involves in homolytic cleavage, loss of CO2, 2 moles CO2 gas will be liberated at anode. So to give CH2 free radical, it have 2 unpaired electron, they involve in bond formation to give ethene. So Kolbe'S electrolysis, it is useful for the preparation of alkenes also. It is useful to preparation of alkenes also. So it is not intermolecular Kolbe'S electrolysis, it is intramolecular Kolbe'S electrolysis. It is intramolecular Kolbe'S electrolysis. So alkene and carbon dioxide liberated at the anode. Okay, so another step is common on electrolysis. H2O undergo dissociation, H plus and OH minus ion. At cathode, H plus ion accepting the 1 electron, it is converted to hydrogen atom. 2 hydrogen atoms combine to each other to give hydrogen gas. Hydrogen gas liberated at cathode. So remaining part, OH minus and Na plus ion. Na plus ion combined with OH minus ion to give NaOH. After completion of reaction, the solution contains basic character. The pH is greater than 7. Okay. So dicarboxylic acid salts undergo Kolbe'S electrolysis to give alkene. So in this reaction, the reactant contain more number of carbons than compared to product. So here reactant contain 4 carbons, the product contain 2 carbons. Okay, so reactant contain more number of carbons than compared to product. So unsaturated carboxylic acid, for example, unsaturated carboxylic acids, for example, malic acid. So you see another example. This is the malic acid salt. sodium salt of malic acid. It is a 6 isomer. On electrolysis, okay, so it undergo oxidation. At anode, loss of 2 electrons. It is converted to free radical. Now it involving homolytic cleavage, loss of CO2 to give CH double bond CH, free radical. Now this free radical involve in bond formation to give acetylene. Okay, so this is one of the product. So Kolbe'S electrolysis, it is useful for the preparation of alkanes and alkynes also. So another one, it is useful for the preparation of cycloalkanes. Okay, so now you see another example, cycloalkane. All these are the intramolecular Kolbe'S electrolysis. You see another example. Now this compound contains how many number of carbons? 1, 2, 3, 4, 5, 6. So the product contains less number of carbon atoms. So this are involved in removal of CO2. Okay, the product contains how many number of carbons? Only 5. Okay, because it contains, so it contains how many number of carbons? 1, 2, 3, 4, 5, 6, 7. So 7 carbons. So it loss of 2 moles of CO2. Okay, so first it converted to carboxylate anion. At anode, it undergo oxidation. Now it involved in homolytic cleavage. Loss of 2 moles of CO2 to give. Okay, so now they involve in bond formation 1, 2, 3, 4, 5 to give 5 member ring. To give cyclopentane. So it is an intramolecular Kolbe'S electrolysis. So Kolbe'S electrolysis, it is useful for the preparation of alkanes. So alkanes and alkynes, and also cycloalkanes. Okay, Kolbe'S electrolysis, it is 2 types of reaction. One is intermolecular Kolbe'S electrolysis, another one is intramolecular Kolbe'S electrolysis. Okay, Kolbe'S electrolysis, it is not suitable for the preparation of methane and also not suitable for the preparation of odd number of hydrocarbons. Kolbe'S electrolysis, it is suitable for the preparation of even number of hydrocarbons. So in even number of hydrocarbons, it contains 2 to 18 carbons. Okay, the carbon chain contains 2 to 18 carbons. It gives a good percentage of yield. So alpha substituted carboxylic acid salts, they give less percentage of yield. The steric crowding increases, the percentage of yield decreases. When alpha substituted carboxylic acids involving Kolbe'S electrolysis, they give the percentage of yield is less than 10%. They give the percentage of yield less than 10%. Okay, so in Kolbe'S electrolysis, the reaction mechanism takes through free radical mechanism. Okay, at anode, which gases are liberated? Carbon dioxide and hydrocarbons are liberated. At cathode, hydrogen gas is liberated. After completion of reaction, the solution contains basic character, the pH is greater than 7. So exception is sodium formate undergo Kolbe'S electrolysis, hydrogen gas liberated at anode, hydrogen gas liberated at a cathode. Okay, this is a important. This is a Kolbe'S electrolysis. Okay, so tomorrow we discuss about the reaction mechanism.